Okay, good morning. This is now Unit 8, Section 2, the second worksheet, graphing inverses. So there's a couple different ways you can do this one. And I would recommend using Desmos. That would be Desmos graphing calculator. So that's highly recommended that you do it on this one. Okay, because you're going to graph this one, and then you're going to, once you have the inverse, you'll graph the inverse as well. So on this particular handout, I'm going to have to solve for the inverse. So I can, if I graph this one using Desmos, it's not too bad. Looking at the graph from Desmos, it goes through 2. It kind of winds up going this way and has a point of inflection right there at 2. And then kind of goes in this direction. Okay, so that's what Desmos gives me for the first one. Again, graphing this one right here. Now if I solve for the inverse, I'm going to rewrite it as y equals negative 5x minus 2 cubed. Now switch my variables. So x equals negative 5 y minus 2 to the third power. Now I have to go through and solve this for y. Again, that's a repeat. Solve for y. Again, I graphed the first one using Desmos. Piece of cake here. And if you want to, you can just let all of that be y on Desmos instead of typing in f of x. Okay? So here we go. Sorry about that interruption. So now the next step, when I solve this, solving for y, I'm going to divide both sides by negative 5. Okay, so now over here, I have x over negative 5 equals y minus 2 cubed. Okay, so because the negative 5s will cancel. Then after that, to get rid of the cube, I need to cube root everything. Yikes. Alright, so now I have cube root of x minus 5 inside that. That equals y minus 2. Then the last thing is I'm going to add 2 to both sides. So this is a crazy equation. Alright, so we have the cube root x. Okay, again, all that is under the cube root. X divided by negative 5. Then outside that symbol, I have plus 2. And that will equal y, which is going to be my inverse. Okay? So this is the next one you want to graph, this right here. Now if you graph that one, it has an inflection point at this 2. Okay, so I'm going to put a little dot at 2 here and draw it and going up this direction, and then it's going to come down and start going past, just barely past 3 as it goes down. And if you notice, what's nice about these graphs is they are all going to be reflected around this line for every single graph you draw. And this line is called y equal x. So they reflect over the line y equal x every single time. So keep that in mind when you draw your graphs, when you're all done, that you can see if you were to draw this dotted line, they will reflect over that dotted line. Alright, let's try one more, see how you do. Number 3 down here. First thing I'm going to use is Desmos again. Okay, again, always use Desmos graphing calculator. You want to graph these. You don't want to plot points, it's going to take too long. Okay, so if I graph this one right here, this is probably the graph I'm going to get. I have a vertex at negative 3, and then one side tails up this way, and the other side tails up that way. So it looks like it's a parabola because it's a square. So this is your quadratic equation. Now, if I do the work to solve this, I'm going to, again, off to the side somewhere, substitute, again, right, substitute y in for f of x. Y equals 5 then, x plus 3 squared. Flip-flop my x's and y's. You get y plus 3 over 2. Okay, now at this point solve for y. Always solving for y. So first thing I would do was divide by 5. So I'm going to have x over 5 equals y plus 3 squared. And then what cancels the square symbol? And that would be your square root symbol. So then that gives me x over 5 is equal to y plus 3. Then just take away 3 from both sides. So the equation for the inverse is the square root of x over 5. Take away 3. And then proper inverse notation right here. Okay. So now if you graph this one, again using Desmos, don't forget to do that. I have the vertex sitting right here, and the graph goes this direction and then this direction. Okay. So one thing to keep in mind, if you think about functions, the original is a function. Okay, if I do my vertical line test, then just to be a little extra here, this is a function, but the inverse is not a function. Okay, and one thing we can determine that is because the vertical line test tells me whether the original is a function, but if I do what's called a horizontal line test on the original, it'll hit in 2 spots. Something to keep in mind. So there's really a couple tests we can do. Vertical line test, and there's also one called the horizontal line test. So the first one tells me, if I do a vertical line test, it tells me that the function itself is a function. Okay, if the original equation is it a function. The horizontal line test then will tell me, is the inverse a function? In this case, vertical would be yes on the original, but no on the inverse. Again, we can actually, if I just do the inverse and I do vertical line test, this is definitely going to be a no. And let's draw that dotted line. Okay, again, dotted line. This represents the equation y equal x. Okay, and they will be reflective over this line, and sure enough, if I were to take that and reflect it, it reflects right there perfectly. Alright, I'll let you guys do the other 2 on your own. Again, this takes a lot of work, but it can be done. Again, this is the last worksheet on Unit 8, Section 2. Again, always double check your answers with the answer sheet.